Hello everybody, we're going to look at another example of using the mean value theorem. This example is a little bit more in depth, so let's go ahead and get started. Okay, so we are going to prove that the absolute value of sine A minus sine B is less than or equal to A minus B in absolute value, okay, for all A and B. Okay, so the first thing we're going to do here in the proof is decide which one of A and B is larger. Okay, so we're going to assume that A is the smaller one because that's what we normally do. Okay, and if that's not the case, we're just going to rename them. Okay. Okay, so we're just going to rename them so that A is the smaller one. Okay? All right. So we want to go ahead and use the mean value theorem here. So what we need to do is look at a function, right? And if we look at the right side of the mean value theorem, we can see that we have f of b minus f of a over b minus a, right? And this is looking real similar to sine of a minus sine of b over a minus b, right? So what we want to do here is we're going to let our function be sine, right? We're going to let f of x be sine x. Okay. And we're going to consider the interval AB. Okay. Now, we know that sine x is continuous on R, right? We know that sine x is always continuous. Okay, and this is something that we said in the last couple of examples, but I really want to emphasize this because it is so important. It's not enough to say this, right? You want to be specific in saying that it is exactly continuous on this closed interval that you are interested in. Okay, then we're going to check our second condition, that it's differentiable on the open interval AB. Okay, so we're going to look at f prime of x. Okay, we know that for sine, the derivative is cosine. Okay, which is defined everywhere. Okay, we want to say, again, specifically, f is differentiable on the open interval AB. Okay, now, because we've checked the two hypotheses, we can use the theorem here, okay? And every time we use a theorem with a name, we want to say which one we're using, right? So by the mean value theorem, there is a C in AB, so that right, so now let's conclude. F prime of C is equal to, right, F of B minus F of A over B minus A. Okay, so let's write out what that means for this particular function, right? F prime is cosine, so this is going to be cosine of C is equal to F of B, which is sine of B, right, minus sine of A over B minus A. Okay? Now, in order to get this really looking like the thing that I'm trying to prove, I'm going to go ahead and reorder sine A and sine B and B minus A. Okay? So I have minus sine A plus sine B over negative A plus B is equal to cosine C. Okay. So what that means, I'm going to factor out a negative 1, right? So I have sine A minus sine B over minus B minus A. I'm sorry, A minus B. That's the whole reason I switched them. A minus B. Okay, and now you can see that the negative signs are going to cancel. All right, so I have sine A minus sine B over A minus B is equal to cosine C. Okay, now I need a fact about absolute values that we're going to describe right here. Okay, so if x and y are equal, okay, then it's true that their absolute values are also equal. Okay. All right. So in this case, I am going to take the absolute value of both sides. So sine A minus sine B over A minus B equals the absolute value of cosine C. Okay, now we need a fact about cosine. Okay, so we know that cosine is between -1 and 1 for any value of C. Okay, and what this means is that the absolute value of cosine is going to be less than or equal to 1. Okay, so I'm going to use this information, right? So I know that sine A minus sine B over A minus B is equal to cosine C, right? The absolute value of cosine C, which is less than or equal to 1. Okay, so I can conclude, gotta squeeze this in here. Less than or equal to 1. Okay, so what I can conclude here is that sine A minus sine B over A minus B in absolute value is less than or equal to 1. Okay. Now I need to make some space for myself. So I'm going to go ahead and erase what I already have, but I'm going to copy down what that first line says. Okay. Okay, so what I had was that the absolute value of sine A minus sine B over A minus B was less than or equal to 1. Okay, now I need another fact about absolute value. So if I have the absolute value of x over y, this is equal to the absolute value of x over the absolute value of y. And I'm going to use this information now. So I'm going to split up my absolute value. Divided by absolute value of A minus B. Okay. And now you can see I'm really close to the inequality that I'm trying to prove. I want to multiply both sides by A minus B, okay? But I need to explain that the reason I am allowed to do that is because this is the absolute value and it's positive, okay? Right? If this wasn't positive, I would have to change the inequality symbol. So it's super important that this is an absolute value for this part, and we know that this is positive. Okay? And that's what we wanted to show. All right, that's the example that I wanted to do for this video, and I will see you guys in the next one.